almost absolutely everything on the Netflix homepage is personalized. You would see a certain art for every single show that would also be personalized and different for each users. On top of that, when you would hover on top of a show and it would like show some sort of replay or clip, what clip it would play was also personalized.
Welcome to Interlude, where we talk about the transition between the pre-AI and post-AI world. I'm Jake, one of the co-founders of Whitney AI and a co-host of the podcast.
I am Vatsal, one of the co-hosts of the Interlude Podcast and one of the co-founders of Whitney AI.
So today, I want to talk about Vatsal's experience here. He has a lot of experience in both model serving, so deploying models to production, and recommendations. So you're the expert. Can you tell me a little bit about where you've worked and what you did at those companies?
So I have about 4 to 5 years of experience working in model inference and serving. I worked at Microsoft for about 3.5 years, and then I worked at Netflix for about 1.5 years. At Microsoft, I worked on the recommenders platform. So we served all the models that you would see on Microsoft Edge. So as soon as you open up Microsoft Edge, you see a bunch of recommendations happening. You see the news page, you see the finance section, even the weather app that used to be there in Windows 10 was powered by recommendation, and even Bing Copilot. Like sometimes, you would recommend what prompts on Bing Copilot. So all sorts of recommendations at Microsoft. And then at Netflix, I did model serving for, again, recommendations, but also a wide variety of different use cases, which included like fraud detection on payments on the Netflix webpage, or password sharing detection was also one of the use cases that I worked on.
I'm curious to learn more about the personalization aspect of it. And it might be a little bit helpful because a lot of people use Netflix. Like when I log into Netflix, what is being recommended to me? How are the ML models working there?
Almost absolutely everything on the Netflix homepage is personalized. The first thing that you see is the billboard, which is like the one big show, and that will be personalized to what you like. Then for what we used to have when I was there early on, we had like row level recommendations. So there was like a continue watching row, and then there was top 10 in the US, and there were a bunch of different rows. Each of those rows would be personalized as well. The artwork on the show, like you would see a certain art for every single show that would also be personalized and different for each users. On top of that, when you would hover on top of a show and it would like show some sort of replay or clip, what clip it would play was also personalized. And every single one of these were different things, and we had different sorts of models running for each of these personalizations. So the stack was pretty deep.
So walk me through then how, let's say you have like the first thing that you see, the big like
the billboard.
Yeah, the billboard. How does me logging in, like how does Netflix know how to recommend that, and how is it so fast? Because It's almost instant, right?
Yes. So we do a lot of inference optimizations, and one of the inference optimizations technically is just pre-computing. Mm-hmm. So the day before or the day off in the morning at some point, like we every single day we essentially run pipelines and a lot of different big tech companies do the same, where we would pre-compute the rankings. Essentially, in recommendation space, we call these rankings because it's like you're essentially ranking TV shows for each human being that comes and visits. So your rankings were pre-computed that same day, and we sort of know that if you were to visit this day and at a very high availability, so the service never crashes for you, and that all of the models that are running are really fast so that the experience is seamless for you. That was one of my jobs.
You keep mentioning like model serving. Is that different from like inferencing that a lot of people know with like LLM use cases? Or is it the same term? Like, could you tell us more about that?
My interpretation of this is that inference is a subpart of model serving as a whole. And model serving is essentially the whole field of what to do when someone has trained a model. What is a model, first of all? Yeah. In my head, a model consists of 3 things. You have weights, the weights of a model, And then you have the actual code that's been written, which is like the logic that's going to take place, and then dependencies of the code. So if a certain Python library is being called, that's like a dependency. So in my head, a model consists of weights of the actual model that have been trained, the code, and the dependencies. So once someone has trained a model, what to do after that? That whole field is called serving. And that this includes observability while the model is in production. And this also includes the inference bit, which is essentially just when you train a linear regression model and you just do dot infer on it, or you just like run the inference on it, that is called inference. So that's just one part of the step.
Interesting. And which part did you work on, or did you work on all like parts of the stack?
So I worked on all parts of the model serving stack,
Awesome.
Including inference. Yeah.
And were these like more traditional ML models, or were they like LLMs? Like
there was a mix. Yeah. So it depends on the use case. So when I was at Microsoft, LLMs were only coming out a little bit like towards the end of my time. So it was mostly classical machine learning models. Like we would have like decision tree based recommender systems. At Netflix, we would have like neural net based recommender systems. And now, while I was there, they were also working on generative pages and generative recommendations. So what that means is using the transformer architecture, which is like the architecture behind large language models today, to generate recommendations. So that's called generative recommendations. And what that essentially means is you recommend things on a sequence by sequence basis. So imagine the Netflix homepage for you, right? You log on to Netflix and you see all of the episodes that are personalized in one go. Previously, I told you it would be row-based. Every row would be recommended.
What is a row here? Just to click.
A row is just like, like a continue watching row. Or you say top 10 in the US is a row. Or because you watched X show, that is a row. The page consists of rows and columns because it looks essentially like a table. With transformer architecture, you can do sequence-based recommendations. So as soon as you come on the page, it'll generate instead of the first token, it generates the first episode, and then auto-regressively generates every next episode. That's just a different way of doing the recommendations.
I see. And did Netflix have, could you give us examples of like some LLM-based recommendations that they had? I guess you just gave one, but is there like something more like the users would interact with?
Yes. So generative recommendations is one way of doing recommendations. And the more simple thing that Netflix came up with was called, when I was there, was called Conversational recommendations. They changed the name of this feature a few times, but they've published blog posts online about it. Essentially, it's just a chat interface. And if you're a user, you can go on there and say, I'm feeling sort of sad today, and it'll recommend you the sort of movies that you might want to watch. So it's more of a traditional LLM, which it will recommend you content. Interestingly, this was hosted on OpenAI before, but then Netflix moved to hosting these models internally.
Was it like open source models or their own models? Like, do you know?
As far as I know, we did not pre-train. We don't pre-train our own models, so it was based on open source models.
Mm-hmm. Yes. Interesting. I'm trying to wrap my head around this because recommendations is kind of like a hard thing to measure if you're doing right. Like, how did you know what to even optimize for? Like what are you trying to achieve with recommendations? Like, what is the business outcome that like the engineers can work towards?
Yeah. So, the business outcomes differ by different companies. So if you see, let's talk about Netflix first, then I'll talk about Microsoft. Because Microsoft, I was more directly on the recommenders team, and at Netflix was model serving and inference. So recommendations was like one part of one of the use cases that we worked with. So at Netflix, if you look at SEC filings, what Netflix cares about is how long does a user stay on the page. Netflix will care about how fast can they find, like in recommendations, we really care about how fast can you find relevant content for you. And then you actually stay on that content and watch the whole show. Because really you want to optimize for the users being on your platform the longest. That's what makes money. And that's what causes stickiness so that you know the users are liking the product. So in recommendations, what matters the most is relevance of the content. That if you, Jake, if you want to watch a K-drama is what we will show you as number one. And the K-drama for you, you don't have to think. You go on the platform, first thing you click is what you watch, and you finish the show. That is perfect recommendations.
Sometimes I like to watch Bollywood movies, though.
Okay.
Doesn't have to always be K-dramas.
Which ones? Do you know any?
Oh, yeah. I watched Veer Zara. That was a good one.
All right.
Khan. Yeah.
I will keep this in mind and let my Netflix friends know so they can edit your recommendations.
Yeah, for sure. But yeah, you were saying about like what to
Yes, what to optimize for. So that's what Netflix optimizes for. And then there was Microsoft, right? Microsoft Edge recommendations mattered quite a lot because we would make money on ads. Every time there would be lower relevance, less people would spend time on the browser page and they would not click on the ads. So that would lose you money directly. So at Microsoft Edge, recommendations and relevance mattered a lot. And the business metrics that they cared about was essentially, similar, that you stay on the platform longer, that you click on the ads.
And how did you measure like these metrics in practice? Like, how do you even test for that? Like you mentioned like the what you measure for, but like how do you do that?
So what we would do is whenever you would have like feature changes or you would have a new model that was released and you wanted to test if it actually moved the metrics for you or not, the best way to do this is do an A/B test. So randomly, select a group of users and send them one version, and randomly select another group of users and send them another version of the model, and see which performs better on the metrics that we care about. So Netflix employed A/B tests quite a lot, and so actually at Microsoft, the frequency of A/B tests was a lot more. Interestingly, at Netflix, we would very selectively A/B test products that we thought, had a good chance of succeeding.
Why do you think that's the case? Why do you think like Microsoft did it a lot more than Netflix?
I think it was just organizational. I think at one point, if you run too many A/B tests, I think there's some sort of like statistical study about this that it dilutes your test itself if you're doing too many A/B tests at the same time. I think the systems at Microsoft weren't as sophisticated.
I see. And I'm kind of wondering though, because I feel like I don't really see like a lot of LLM recommendations in my day to day, or maybe I just don't notice it, right? Like when I'm in DoorDash, maybe they might have implemented this feature recently, but like, they're not really recommending like restaurants relevant to me. Why do you think that's the case? Like, do you feel like LLM recommendations just haven't caught up, or these like tech companies don't adopt them? Like.
So research in the US on recommendations is far, far behind research in China. So China has the super app called Meituan, and there are papers about recommendations. They do generative recommendations already on the fly, and it's way better. For some reason, the US is still catching up. Like even at Netflix, for example, we just started exploring when I was there. They were doing generative pages and they were doing conversational recommendations, which was the chatbot experience. And we were trying these things. But in China, in these super apps, they're already deployed. People are using it in production, and they've figured out how to get the latency really low, and they work very, very well. So, I hope we catch up.
Do you have a sense for like why that's the case? Could it be like regulation or something, or like?
I don't think it's regulation. I think the focus in Silicon Valley right now is to improve models, improve LLMs, seeing how LLMs or transformer architecture can be used for recommendations, and then improving that is an ML problem, but also a systems problem. And I just think China tends towards that sort of research a bit more, while in Silicon Valley, we're all focusing on improving the models and getting the next best model out there.
That's kind of an interesting take, because I feel like a lot of the recent open source models have been Chinese models, right? Like GLM, for example.
That's true. I mean, I don't mean that. I mean, the frontier labs, and in US, most of the bigger companies are focusing on improving the closed source models, while China's focusing on systems and ML and actually deploying them, and also open source models. But even GLM and the open source models that are coming out of China are still not as good or as big as the frontier models right now in the US. Like, I think people say that the frontier models here are more than 1 trillion parameters, so they're fairly large. And on top of that, they perform better on benchmarks.
But at a really high cost, right? Like, and oftentimes like slower latency.
Yes.
Yeah. I also have seen on maybe it was like TikTok or something, but when OpenClaw came out, there was like this video of like a bunch of just regular Chinese people like going to an OpenClaw meetup,
really,
and like installing it on their laptops and like testing it out. And so maybe like adoption in China, or like they tend to be more like receptive towards like trying out new tech and getting like more familiar with like literally things that were released like a couple months ago.
I mean, I really comment the open source modeling that's going on in China. And it's sort of ironic that, in the US, we have OpenAI, and that is arguably the most closed company when it comes to releasing your models in public.
What do you think about the direction in which like China is taking in terms of like open source models versus the US is like closed source? Like, which do you think is the better direction to have, and for companies especially, like let's say enterprises, and which do you think like companies should invest in like adopting?
The field only progresses if people focus on open source models. And we've seen this with open source software. So the field is going to progress a lot more. And I think companies should bet on open source models getting better and better. And the release of GLM and GLM performing so well on the benchmarks only proves that. As time goes on, like information will get leaked from the big labs. And as information, gets leaked, and we know that creativity, like you will see the most creativity when you just put a problem in front of a mass of people, and that's what open source software does. So inevitably, I think open source software and open source models will win out in the long run.
Yeah, that makes sense. I think I have a similar take. There's only so much good that can come from like closed source, and it's the nature of their business. But definitely like open source like drives innovation.
Yes.
Kind of coming back to recommendations though, I'm curious. We've seen a lot of applications today. Where do you think like the field of LLM specifically, LLM recommendations is going? Let's say in like the next 6 months or like the next couple of years.
This is very exciting. I almost envision like generative recommendations that I described before based on transformer architecture becoming really popular. And there are even more fun things you can do. Like you can imagine diffusion-based recommendations. So how diffusion works is, you essentially put noise into an image and then train a model to denoise it. So you can imagine the Netflix page and imagine you ran like a diffusion-based model to try to, essentially recommend content. So there are like many different interesting techniques that you can use to generate recommendations better. And as latency is going to go down, as costs are going to go down for these sort of models and these sorts of architectures, you can get a lot more personalized, much better content on the fly for people. Like as soon as I open my Uber Eats app, I have like all the recommendations that I need. And they're a lot better than what they are today.
Do you feel like too good of recommendations can almost be a bad thing though? Because it kind of feels like it infringes upon my privacy. When I get like, when I'm literally talking with you about, say, a podcast, and then I get recommended a podcast to me to listen to in the next hour.
That's not the problem with the recommendations being too good. The main problem there is the business incentives are misaligned with what's best for humanity. Recommendations in the field, in academic research, we try to optimize for relevance. So what we actually want is for the user to be the most satisfied and the most happy. But what the big tech companies, like for example, Instagram will care about is brain rot content. If that's what gets you on there, that's what they'll keep recommending you just so you stay longer on the platform. So I think the business metrics that they care about, I think that's where the problem lies, and not the fact that recommendations is becoming better and better.
Yeah, so this kind of like reminds me of an interesting take one of my friends had where she was reading the Fei Li book, her biography, and she was saying that, Fei Li, she's like pushing this tech. She's talking about in retrospect like how much like danger can come out of this. But like being the smart person and like the genius she is, like she must have seen like some of the dangers of her like image technology, right, in production, right? Like you can use that for, I'm sure the government uses it to like spy on people, for example. It's kind of like going back to recommendations. It's like the dangers that can come up with recommendations, right? Like should the researchers like inherently put safeguards into like recommendations so it can't be used for bad things, or you let the market decide, but that it's going to like the business outcomes are more towards like brain rot content, for example.
Every new technology has risks. And I would argue recommendations risk is really bad because brain rot content is just not nice. But there are even bigger risks with LLMs, and there are bigger risks with every single technology that comes up. I can't think off the top of my head about how researchers would add safeguards to recommendations, because recommendation research is just about improving the relevance of content for someone else, and the models already exist. So brain rot content already exists. It's upon the companies about whether the enterprises themselves will try to move their business metrics around, or say, honestly, I think it's on the regulatory bodies. The government should do studies, and they should figure out how this sort of content is impacting users and people and their mental health. And when you have data backing this, the government should add regulations around these sorts of things. I don't think technology should stop just because we as a society aren't able to come together and say, hey, this is a bad way of using the same technology and this is a good way of using it. It's like a stick. A stick by itself isn't bad or good. But if I use a stick to poke you, it's bad. If I use it to, I don't know, like start a fire to cook things, it's productive. Yeah.
Yeah, that's a fair take. Ultimately, yeah, it's kind of up to humanity to use the tools. And there will always be bad actors for sure, but hopefully the governments can regulate it in some capacity. Yeah, one last thing about LLMs versus classical ML. What does the work behind like optimizing, like serving those models look like? Because I'm sure like LLMs and classical ML models have different architectures, right? So there's different work to kind of optimize both.
They are very different, and there are some similarities as well. So maybe I can go over some of those similarities. For example, if you were to try to serve a classical ML model or an LLM, you would need some similar things. You would need some sort of model hub. You would need to, as part of the serving team or the inference team, you'd have to build some sort of model hub that people can publish model weights to. You would have
like Hugging Face?
Yeah, exactly like Hugging Face. Like that is a model hub, and then you would have to like define some sort of UX for the people who are training the models to be able to push this. So some sort of like ML orchestrator, sort of like Metaflow or Airflow. So that's something that you would have to do, whether it's classical ML or it's LLMs and generative models. So yeah, you'd have to define the model hub. You would still be caring about the same sort of metrics. You'd still be caring about availability. You'd still be caring about low latency, like all the platform things that you care about. You'd still need to know basic distributed systems concepts and make sure your availability is high based on that you have many different sorts of replicas, what sorts of AWS EC2 instances you're using, like you'd still have to, what sort of sharding you're doing on the model. These are all things you'd still have to care about from a systems perspective. Now, when it comes to like actual inference optimization, and inference optimization first starts with observability. First, you need to be able to see the breakdown of the model. So observability can also be similar between classical ML and LLMs. You want to be able to see the breakdown in the latencies, on when the latency is super high, when it's super low. So you'd need good observability on both things. But the actual techniques for inference optimization might differ. For example, with LLMs, you might use something like speculative decoding, which is a way where you essentially exchange compute for lower latency by using this thing called a draft model. And like there's a paper on speculative decoding, and it like goes over exactly how it works. But essentially you use up more compute and are able to get low latency, which is a different sort of technique that you would use to decrease the latency on LLMs. So yeah, there are different sorts of techniques that you would use between classical ML models versus in LLMs. And by classical ML in recommendations, I mean is we use like bandit models, which is like selection. Or we'd use decision trees, random forests, even neural networks. Yeah.
What does observability look like exactly? Because when engineers think about observability, they think about like Datadog, right? Like logs. Like what, I guess, like tools do you use for that? How are you measuring how would you measure observability for like ML models?
Yeah, we'd have internal tools for that built. Also, there's this tool called Grafana, for example. Yeah, so as long as you can see the breakdown of the graphs, and sometimes you'd have to like do heap dumps to actually try to see in what part of the stack was the latency the highest. So you could use any sort of, like we had internal tools that we'd built out to be able to run heap dumps, to be able to, check the latency metrics on the graphs. And you could use Grafana and Datadog for logs. Like sometimes at Microsoft, I would actually look at the raw logs on the machine and check how long, each part of the system took.
Is that kind of like manual work that you had to do as an engineer? Like
it was kind of manual, and I think there are way better ways of doing that.
Maybe a startup idea for someone out there?
Perhaps. I mean, there are a lot of observability startups. There's Arise, for example, that's already working on things like that. And I just think at Microsoft, for some reason, we were a little bit behind and we weren't using the latest technology. But there are a lot better tools for doing this exact same thing now.
Yeah. I also kind of got the sense from when I worked at Microsoft that like they just wanted to build the internal tooling for it. Like we had our own version of SQL, right? Like Kusto, like KQL.
Yeah.
And there was just no need for it because you have SQL. Like why would you invent another query language?
I wasn't high up in decision making to find out the reasons for this.
Yeah, for sure. But yeah, that's a lot of interesting info. Hopefully, I learned a lot personally just now, even though I knew what you have done at your previous companies, so that was really helpful. But yeah, that pretty much wraps up this episode of Interlude. Hopefully, we have someone else coming up next that can talk about their experience. That'd be very exciting.
Okay.
Yeah.
Thank you, Jake.
Yeah, of course.
See you.